Hello guys, welcome back to this new video in my YouTube channel. In this video we're going to be solving the Norwest Mock 2015 as equation on ladder problem, because I uploaded the first video on ladder problem last week. This is the second video on ladder problem. Before we start, please, if you're new in this channel, make sure you subscribe so that you always be notified when I upload another video. Okay, let's get started. The question read: a uniform rod AC of mass 2m and length L rests with one end A against a rough vertical wall and the other end C on a rough horizontal floor. The vertical plane through the rod is perpendicular to the wall. A load of mass 3m is attached to a point B on the rod so that BC is equal to 1/3 L. The coefficient of friction between the wall and the rod and between the floor and the rod is U and P respectively. Please make sure you understand this line very well. Given that theta is the angle between the rod and the wall when the rod is at the point of slipping, show that 5p cot theta is equals to 2 minus 3pu. Okay, before we start, please, I want to tell you something. This video is somehow different from my previous videos, because in this video I've typed everything already, so I'll just be explaining as we proceed. Before that, I told you guys that when you want to solve equation of mechanics, especially math mechanics, you have to draw your diagram first of all, because if you don't draw your diagram, then what you'll be doing will be somehow out of the topic. You may have the answer correct, yes, but the probability is very low. So that's why I usually prefer to draw a diagram first. Okay, they said a uniform rod AC of mass 2m. This is my rod here that I've drawn already. Yeah, this is the rod AC. You can see this is the point A and this is the point C of mass 2m. So, you know, the mass, let me just say the weight is the mass times g, that's the acceleration due to gravity. And the weight of a body usually acts but in the middle. So we are going to assume that this is the middle here. This point here, we are going to say this is the middle here, this point is the middle. Okay, we have 2mg. The mass is 2m and the weight is the mass times gravity, that's g, making it 2mg. Okay, let's continue. What again? And then a rests with one end A against a rough vertical wall and the other end C on a rough horizontal floor. Okay, that's one end A on a rough vertical wall and the other end C on a rough horizontal floor. Now, when we say rough, that means there is friction automatically. That's the meaning of rough. That means there's friction. And if there's friction, we know very well that friction opposes motion. Okay, let us just take an example. If this ladder has to slip, that's from this top here, if this ladder has to slip, you have a tendency to be going back down like this, to be going back down. So since friction opposes motion, then the frictional force will be going back up. So that's why I call my frictional force F2. Yes, you can call it any, in fact you can just give it any letter of your choice, yes, but I prefer to give it F2. So since the ladder will be going back down, that's why the frictional force will be going back up, since friction opposes motion. Hope it is clear. Now, same thing here. If the ladder is sliding, then the ladder will have the tendency to be going back like this. Yes, like this. That's vertically. And friction opposes motion, so the frictional force will be going back in the other direction. I can just say the negative x direction here, something like that. I think that's all what I wanted to say. Let's continue. A load of mass 3m is attached to a point B on the rod so that BC is equals to 1/3 L. That's it. That this is the point B. That means the distance from here to here is 1/3. That's from B to C is 1/3 L. The mass of the object was 3m. the weight now of the object will be 3m times g, that's 3mg. Okay, I think that's all about the question. The question of friction between the wall and the the question of friction between the wall and the rod and between the floor and the rod is U and P respectively. Take note of this. They say the question of friction between the rod and the wall, and between the rod and the floor is U and P respectively. Okay, meaning that the question of friction between this ladder and the wall is U, and between this ladder and the floor is P. Now, I said F1 is the frictional force. But what is the frictional force? Frictional force is the coefficient of friction times the normal reaction force. This is the that I wrote somewhere up here. That's frictional force F1. The coefficient of friction P times the normal reaction force will make the frictional force. Hope it's clear. Same thing here at the point A, that's F2. The frictional force will be the coefficient of friction times the normal reaction force. The normal reaction force at point A is R2. Why that at point C is R1. You can call it any, in fact you can give it any letter of your choice. Yes, you can see this side and name this one R and the other one S. I think that's what I did in my first video. Okay, after that, given that theta is the angle between the rod and the wall when the rod is at the point of slipping, show that 5p cot theta is equal to 2 minus 3pu. They said theta is the angle between the rod and the wall, not the rod and the floor. Take note of that also. It means that theta will be somewhere here like this, up. Yeah, somewhere here up. Now, when solving ladder problem, we always have 3 basic steps. That's you are going to resolve vertically, resolve horizontally, and take moment or torque, anyone. Yes. So let us start by resolving vertically. Resolving vertically, you realize that you have R1, that's forces that are going up. We're going to consider that forces that are going. What did I even write here? Okay, I just equate both sides, meaning that forces that are going up balancing with the one that are going down. That's at equilibrium. You realize that the forces that are going up are R1 and F2. So that's why I wrote there that R1 plus F2 is equals to 3mg plus 2mg, because these two forces are going down. Okay, from there now you realize that R1 plus F2 is equals to 5mg. That's just simple addition. From there now you have R1 is equals to 5mg minus mu R2. Why like that? Just because F2, who is F2? I said earlier that F2 was mu R2, so that's why you have when F2 crosses becomes minus mu R2. That's it. Okay, we're going to resolve parallel. Okay, resolving parallel, I said R2 is equal to F1. Let us check and verify if this is correct. R2. Okay, this is R2 here, go in the positive x direction, and F1 going in the negative x direction. You realize that since they are going in the opposite direction, this guy, R2 is equals to F1. Perfect. But what is F1? F1 is simply PR1. Okay, so that's why you had R2 is equals to PR1. From there now, you realize that R1 will be equals to 5mg minus UPR1. From this equation, from equation 1, we had that R1 was equal to 5mg minus mu R2. But we have been told that R2 is equal to 5PR1. R2 is equal to PR1. So when you replace R2 with PR1, you have a negative UPR1. Hope it's clear. Now you bring R1 the other side. You have R1 plus UPR1 is equal to 5mg. From then on, you can factor out R1 here. When you factor out R1, you realize that you have something like R1 will be equals to 5 mg divided by 1 plus UP. Okay, I think this one is okay now. Yes, I think so. But if you have any problem or any worry, please feel free to comment. I will always respond. And the next part is moment. We are going to take moment. Okay, we know very well that moment is simply the force times the perpendicular distance. So actually we have to resolve these forces perpendicularly to the ladder. Perpendicularly. Okay, as I earlier said, this is the angle here between the rod and the wall, not between the rod and the floor. Take note of that. Very important. Okay. Since this angle here is theta, let us start from point C. From point C. Now I'm to resolve R1 perpendicular to the ladder. Perpendicular to the ladder. Meaning that the line will be somewhere like this. Yeah, somewhere here. Then I'm having R1 sine theta. Why R1 sine theta? We know very well that Z angles are equal. So if this is theta, then automatically here should also be theta. This point here should also be theta. Yeah, that's Z angles should also be theta. But since this line here, this line, I mean this R1 sine theta is far away from theta, that's why you have R1 sine theta there. I told you in the first video that when it is far, it is sine, and when it is close, it is cos. Okay, let's continue. Now we have F1, that's the frictional force, F1. Realize that if this is theta here, this is also theta, as we earlier said, yes, this should also be theta. This point here, this point I'm tapping theta. And realize that this point is close to this line, so that's why you have F1 cos theta. Okay. Now, if this point, now we are on point B. Now, if this is theta here, then automatically here should also be theta up here. But since this line is far away, because we are making such a way that this line should be somehow perpendicular. It should be somehow perpendicular, because if you realize you have the line between, I mean the angle between 3mg and the ladder is not up to 90 degrees. Yeah, so that's why you have to extrapolate to at least adjust in such a way that it will be 90 degrees. Yeah, you understand now? Yeah, so if this is theta, this line here is far away from theta, so that's why you have mg sine theta. I mean 3mg sine theta. Yeah, since the width was 3mg, so that's why you have 3mg sine theta. Same thing here, if this is theta here, so here will also be theta. This point here. Okay, so here you are going to have 2mg sine theta, since it is far away. Okay, I think that's clear. Now, yeah, you could still resolve this one if you wish. Yes, if you wish, but just that the reason why I did not resolve this was simply because I'm going to take moment about point A. Yes, I know very well when I take a moment about the point, that means all the forces or all the moment that are acting on that, yes, let me just say all the moments acting on that point will automatically be zero, because moment will be the force times the distance. If I'm taking moment about point A, then the distance from point A to point A will simply be zero, and anything times zero will be zero. You understand now? So yes, so that is why I did not even bother myself to be writing f2 cos or sine, things like that. Okay, but I think this one is clear. I think this, but as I earlier said, if you have any problem, please feel free to explain. Feel free to mention your problem, then I'll do my best to explain. Okay, that was done. Now we're going to take a moment about point A. We're going to consider that forces that are going upward are going to be positive, and forces that are going downward are going to be negative. Okay, forces that are going upward, we have R1 sine theta only. That's after resolving now. Yes, other one sin theta only. Then these other ones, f1 cos theta, 3 mg sin theta, 2 mg sin theta are just going back downward. That's in the anti-clockwise moment. I mean clockwise moment. Yes, because this law, they said sum of clockwise moment should be equal to sum of anti-clockwise moment. That's when you are taking moment. Now clockwise moment, that means you are going in the direction of the clock. So we have f1 cos theta is going in the direction of the clock, 3 mg sin theta is going in the direction of clock, and 2 mg sin theta is going in the direction of clock. But r1 is going in the opposite direction. So that's why I said sum of clockwise moment should be equal to sum of anti-clockwise moment. Or the total sum of moment at any point should be equal to 0. Okay, now we're going to start moment about point E. Okay. Point E, this point E here, we have negative 2 mg sin theta times half L. Let us verify this one. It's a negative 2 mg sin theta. Okay, it's perfect because it's going the opposite direction. We have negative 2 mg sin theta. Now the distance, don't forget that 2 mg, that's the weight of the ladder, and the weight of the ladder always lies in the middle. I know that from my diagram is not really in the middle, but just that I don't want the point B to be somehow choke. Yeah, so that's why I decided to bring it up a bit. But in my mind, I know that the distance from the weight of the ladder, that's from the center of gravity of this ladder to point E, will simply be the length of the ladder divided by 2. And the length of the ladder was given to be L. So distance from the weight to point A will be L divided by 2. That will make me half L. So that's why you have negative 2 mg sin theta times a half L. Hope this is clear. Now, point B, we have 3 mg sin theta. Now, but what is the distance from point B to point A? Don't forget, we have been told somewhere of that the distance from point A to point is the distance from BC. I mean that distance from B to C was 1/3 L. The distance from B to C is 1/3 L. And we know very well that that's from B to C 1/3 L. We know very well that the length of the ladder is L. It will mean that the distance from B to A will simply be L minus 1/3 L. That's 1 L minus 1/3 L, making it 2/3 L. That distance from A to B, 2/3 L. So that's why you have negative 3 mg sin theta times 2/3 L. Yes, negative 3 mg sin theta times 2/3 L. Okay, let us proceed. Now we are on point C, minus f1 cos theta. Then what is the distance from point C to point E? Distance from point C to point E will seem to be the length of the ladder. That's f1 cos theta. Yes, f1 cos theta times the length of the ladder L plus r1 sin theta. Yes, plus because it is going in the anti-clockwise direction. That's it, r1 sin theta. Okay, that's it. You are equating everything to be equal to 0. I think this should even be the most important step here. That's take a moment like this, because if you don't know how to take a moment like this, then what you'll be doing now will be wrong. Because actually what is now following now be just the calculation. Apart from that, there's nothing again. Okay, from the first step, you realize that I've divided all through by L because L was common everywhere, so I just cancel the L all through. You have 2 mg sin theta times half plus 3 mg sin theta times 2/3 plus f1 cos theta minus r1 sin theta is equal to 0. And I could divide all through by negative. Yes, so that's why here you have positive, and here you have negative. Okay, that's it. In our proof, we are supposed to have cot theta. So for it to have cot theta, you know very well that cot theta is simply cos on sine. That's the only possibility for it to have cot theta. Yes, cos on sine, because when you have sine on cos, it's not more cot. Sine on cos is tan. Yes. Okay, so here what did I do? I'm having 3. I'm not having better mg plus 2mg plus PR1 cot theta minus R1 is equal to 0. Okay, look at something. From here, you realize that these two will take care of this half. You'll be left with mg sine theta. Now, at the same time, I divided all through by sine. Why did I divide all through by sine? Just because I knew that somewhere here I'll be having now a cos on sine that will give me cot. Understand now? Yes. So these two cancel this half, and you're left with mg sine theta. When you divide mg sine theta divided by sine theta, you have mg only. Okay, well, we are done with this one. You have 3mg sine theta times 2/3. The 3 will cancel the 3 down here, and you will be left with 2mg sine theta. Now, 2mg sine theta divided by sine theta, left with 2mg. Perfect. Now, here you have f1 cos theta. f1 cos theta. f1 cos theta divided by sine theta will be f1 times cot theta. But who is f1? f1 was simply PR1. That's, we saw it somewhere up there. PR1 minus R1 sine theta is equals to 0. Now, when you divide R1 sine theta divided by sine theta again, you have R1 only, and 0 divided by any number will simply be 0. So that's why you're having this. Now, mg plus 2mg will be 3mg, yes, plus you factor out R1 here. You have R1 into P cot theta minus 1. Because when you factor out R1 here, you play with P cot theta. When you factor out R1 here, you play with -1 is equal to 0. Perfect. Now, but who is R1? We saw somewhere over here that R1 is equal to 5mg divided by 1 plus UP. 5mg divided by 1 plus UP. Yeah, so that's why you just insert, substitute. You have 3mg plus 5mg divided by 1 plus UP times P cot theta minus 1 is equals to 0. Now, from there, now you multiply all through by 1 plus UP. That's left hand side and the right hand side. Everything, multiply everything plus. We multiply everything by 1 plus UP. When you multiply 3mg by 1 plus UP, you have 3mg into 1 plus UP. When you multiply 5mg divided by 1 plus UP times P cot theta minus 1 by 1 plus UP, you have the 1 plus UP will cancel the 1 plus UP down, and you're left with 5mg into P cot theta minus 1. When you multiply 0 times any number, you should be left with 0. Okay. We just expanded the bracket. But before expanding, we realized that mg is common everywhere. So we decided to divide auto by mg. When we divide auto by mg, you had 3. We divide 5 mg into P cot theta minus 1 by mg, you have mg. When you have 0, you've left with the 5 into P. Now when you divide 0 by mg, you've left with 0. So at the end of the day, when you open this bracket, you have 3 plus 3 UP, yes, plus 5P cot theta minus 5 equals 0. From now you can bring like terms together. You realize that 3 minus 5 is -2. So you have 5P cot theta plus 3 UP minus 2 is equal to 0. And from there now you have 5P cot theta 5 cot theta is equal to 2 minus 3PU. And that's how the proof came out. So you realize that ladder problem is not really something complicated. No, it's not something complicated. The basic, that's for me, the foundation is we have at the level of the diagram. Understand the meaning of rough and smooth. Yes, because we have two words here, rough and smooth. Because they said the ladder was, let me read it again. A uniform rod AC of mass 2m and length L rests with one end on one NA against a raw vertical wall. There's one NA against a raw vertical wall. That means there is frictional force automatically. I need to know the direction of the frictional force. That's F2. It always opposes motion. At the other end, on a rough horizontal floor. Yes, so these are just some of the steps that you can use to answer this problem. Then after that, now you are just resolving forces. Then now you're taking moment. This should be, even the part that should be somehow complex, but I think from the way I was explaining, everything is clear now. Okay guys, thank you very much for watching, and see you in the next tutorial.